Okay. Yellow number 1, yellow number 2, yellow number 3, yellow number 4. What else you got? Blue 1, blue 2, blue 3, and blue 4. Okay? The big terms in this section are mutually exclusive. We're going to talk about it. Write it down. These are your notes. Mutually exclusive and overlapping. You have formulas for each.
What is this called?
Probability of compound events. We need to talk about when two things are mutually exclusive and when are they overlapping. Before we do this example, we're on page 369 in your book. Let's talk about in general in life. Boy, girl. Exclusive or overlapping? I hope it's exclusive, right? You can't be a boy and a girl, right? I hope, right? They are exclusive, okay? How about 16 years old and 19 years old?
Exclusive.
They're exclusive. They don't overlap, okay? How about basketball player and track athlete?
Overlap.
Could those overlap? Could one person do both? Yes, those overlap. How about female and sophomore?
Overlapping.
Could those overlap?
Yes.
Yes, they could overlap, right? We have female sophomore. Those overlap. Are you getting the idea?
Yes.
Overlapping and mutually exclusive. Let's do one more. How about
John and girl.
What?
how about the name Lindsay
And a guy.
and male?
Yeah.
That's
I know a guy named Shelby.
You know any guys named Lindsay?
Yes.
Yeah. Girls named Lindsay?
Yes.
Yeah. Those overlap.
What about
Those
girl
overlap.
named Jake?
All right.
You don't see that.
I called a business one time and a girl answered and it was so weird. She said, she said, hello, this is Jake Collins. And it was a girl and her name was like Jackie Collins or whatever, but Jake was her nickname. It was really weird, you know what I mean, for her. I thought it was like messing with me or it was like deja vu or something. I don't know, it was weird. I didn't know what was going on. It threw me for a loop. I mean, I sputtered for like 30 seconds. All right, here we go. In exercise, here are the directions. Emilio, are you listening? In exercises 1 through 6, you draw a card from a bag that contains 4 yellow cards, numbered 1 through 4. I have them drawn up here in the bag. And 4 blue cards, numbered 1 through 4. I have them up here in the bag. Tell whether the events A and B are mutually exclusive or overlapping. Then find the probability of A or B. That's the important part. Can you find the probability of the first thing happening or the second thing happening? Okay? So let's look at number 1. It says the probability, this is number 1, the probability of a yellow or a blue card. Okay? A yellow card, you reach in there and you pull out the probability of a yellow card or a blue card. The first question, is it mutually exclusive or is it overlapping?
Overlapping.
No,
it's
exclusive.
Can a card be yellow and blue?
Oh,
We
yeah.
don't have any green cards in here, right?
Yeah.
It can't be. It has to either be yellow or it has to be blue. They are mutually exclusive events. Nod your head if that makes sense. You understand that they're exclusive. David?
So if they're green.
There's no green. I was just saying yellow and blue make green. No, there's no green. They're exclusive. Okay? All right, so now let's do the problem. In doing the problem, we'll come up with the formula. What you do every time something is mutually exclusive. What is the probability of drawing a yellow card?
50%.
4 over 8, which reduces to what?
1/2.
1/2. Half of them are yellow, guys. That's pretty easy. The probability of a yellow card is 1/2. What is the probability of a blue card?
1/2.
1/2 as well. All right. Conceptually, see if you can wrap your brain around this. What is the probability of reaching in the bag and either pulling out a yellow card or a blue card? 100%. Outstanding. So we know that this is 1. how can you get 1 out of 1/2 and 1/2?
You add them up.
You got to add them up. And that's what you do every single time it's mutually exclusive. It says it over there, right? Add them up. The answer is 1, but more importantly, the formula is to simply add up the probabilities. Add up the probabilities. That's your formula. Every single time it's mutually exclusive, you simply add them up. Add up your two probabilities. Find the probability of the first one, find the probability of the second one, and you add them up. Now that's a little different. What did we do yesterday? Right, when we said 6 pairs of pants and 4 pairs of shirts, what did you do then? You multiply. Okay, this is a little different. We weren't talking about probability there. We were talking about choices. Yes?
So just for mutually exclusive, you add the
Yeah,
probability?
this one has a different formula. We're going to talk about it. Example 2 is overlapping, so we're going to talk about it in a second. Anybody else? Good question. All right, so if it's mutually exclusive, what do?
Add them up.
Find the two probabilities and then
Add them up.
add them up. All right, so let's talk about overlapping. Overlapping. Event A, it says you choose a blue card. All right, so here's the probability of a blue card. Or, what is the second part? What, number 2, guys. We're doing number 2. What's the second part? A number 3 card. Okay? Do those events overlap or are they mutually exclusive? They overlap. Why? Because there's a blue number 3 card. They overlap. Right? Think of it like this. Think of it like this. What is this called?
Venn diagram.
Venn diagram. If this was all the blue cards and this was all the number 3 cards, what would you have in the middle?
Blue number three.
A blue number 3. They overlap. Right? There are some basketball athletes that run track. They overlap. Some people just play basketball. Some people just run track. But there are a few dual sport athletes that do both. Okay? That's overlapping. That's a real world example. Alright? This one has a different formula. We're going to discover the formula as we go through it. Are you ready?
Yes.
Alright. What is the probability of a blue card? We already figured it up on the earlier problem. What is it? 1/2. Very good. Probability of blue. I'll do it like this. 1/2. What is the probability of a number 3 card?
1/4.
1/4. How'd you get that?
Because it's 2/8 simplified.
There are 2 of them. And how many total cards are there? 2 over 8 reduces to 1/4. If this was mutually exclusive, you would add them up and you would be done. But they're not. They overlap. So, let me see if I can explain it. Guys, why are there only 5 or 6 of you looking back here? I know some of you are writing down, but all of you should be looking my direction. I don't understand how you can get this information without watching me do it. If I add up all of this, and I add up all of this, I will have counted the middle part twice. So to get the correct count, what do I need to do? If I add these two, what do I now need to subtract out?
The middle part.
The middle part. And what will that be? The probability of what? Of blue number 3. So I add up the first part, all of the blues. I add up the second part, all of the number 3s. But then I have to subtract out the middle part because I counted it twice. What is the probability of a blue number 3?
1/8.
1/8. There's only one blue number 3 card in the bag. Only 1 out of 8. You do this on your calculator, or you know how to do fractions, find the lowest common denominator. You add 1/2 and 1/4, you get 3/4. You subtract out 1/8, and the answer is 5 over 8. 5/8. Write that down. Write this down. The formula, hold on with your questions. The formula is that you add up first 2 parts. Then you subtract what would we say we subtract out? I was overlap. Let's say we subtract the overlap. The thing that they have in common. You can put that common. parentheses. All right, now questions. Everybody's got this written down. You write that down, then you can ask your question. Love it?
I got lost at the part where we were finding the probability of number 3, part 3.
Probability of the number 3. How many
How did
number
you get
3s are up there?
2,
2 over what? How many total?
8,
What's 2 over 8 reduced to?
140.
There you go. Okay. Savannah, you good? All right. So in review, see, we kind of discovered this. Instead of me just giving you the formulas, we kind of discovered these formulas through these 2 examples. So in review, if they're mutually exclusive, it's very easy. What do? Find the 2 probabilities and do what? Add them up. If it's overlapping, which most of them are overlapping because it's harder, you add up the 2 probabilities, but then what do you have to do?
Subtract the overlap.
You have to subtract the overlap. And that's the hard part. It's not hard to figure out whether they're exclusive or overlapping. It's hard to figure out what these 2 probabilities are and what the overlap probability is. That's the hard part. Okay? Now what I want you to do, and then we're going to talk about it, is I want you to do 3, 4, 5, and 6 on page 369 now at your desk. Finish out that page now at your desk. Now at your desk. 3, 4, 5, and 6. We're going to go over it in about 5 minutes. 5, 10 minutes. Okay? You at your desk are trying the rest of that page.